Distance formula. Distance formula can be represented in two ways. The main way is using the formula. That's going to be x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of that entire answer. Really what that's doing is the difference in x is finding your run for the change in x, and then that y2 minus y1 is your vertical change, which is your change in y, and that's going to be your rise. So rise and run, again, associated with a line on a coordinate grid, are finding a hypotenuse of a right triangle. And what the difference in x is A or B on the legs of a right triangle. So that also coincides with a squared plus b squared equals c squared, Pythagorean theorem. And you can see I have both notes written, and you can see how they both kind of pan out the same. They just look a little bit different. So it kind of depends on how you want to do it. The formula always works. I'm going to be using the formula through the examples. So I went ahead and included the formula down there. That'll always be included for you on your reference materials. So we always start by labeling our x and y values. So x1, y1, x2, y2. That way we're not making any simple mistakes. So x2 minus x1, so 10 minus 2. So 10 minus 2 squared plus the difference in y's, y2 minus y1, which is 1 minus 7. 1 minus 7 squared, and we're going to take the square root of that entire thing. So now we're going to simplify inside the parentheses first. That's going to be 10 minus 2 is 8 squared, plus 1 minus 7 is negative 6 squared. Square root that whole thing. Now we can actually square them, and then we'll be able to combine those two terms, and then we'll have the square root of what that is. So that's going to be 64 plus 36 square root. 64 plus 36, ooh, this one's nice. Square root of 100, 10. So really what we were looking at here is we had a point, say we had a coordinate grid. We had a point here, and then we had a point here. What we did is we counted how far over, we counted how far up or down to find the length of a straight line connecting those 2 points. So some algebraic reasoning coming in here, all kinds of stuff. Let's go ahead and start another one. So x1, y1, x2, y2. So x2 minus x1, that's 7 minus 10. 7 minus 10 squared. Plus y2 minus y1, 3 minus 7 squared. Square root. 7 minus 10 is negative 3 squared, plus 3 minus 7 is negative 4 squared, square root. Negative 3 times negative 3, positive 9, plus 4 times negative 4, positive 16, square root. Oh, this one works out nice too. 25. Square root of 25, 5. So the two legs of the right triangle that are created from the slope of the line that would connect these 2 points were 9 and 16. And that was after we had squared them. So that was the a squared plus the b squared. Once we combined them, we then were able to have the square root of c, which is 5. Okay, so technically this is a 3, 4, 5 right triangle. Let's go ahead and do the last one. x1, y1, x2, y2. All right, so x2 is 10, or 2, and then x1 is 10, so 2 minus 10, square it, plus 4 minus 10, square it, square root. Simplify inside the parentheses, it's going to be negative 8 squared, plus negative 6 squared, square root that whole thing. Negative 8 times negative 8 is going to be 64, plus negative 6 times negative 6, 36, square root the whole thing. That's going to be the square root of 100 again, 10. So these are very straightforward, very simple examples. The only thing that's going to come up that would be a little more technical would be whenever it's not a perfect square being worked out, and then you have to simplify using square roots.